Hello everyone. In this video, we are going to learn how to solve knapsack problem using dynamic programming. First, let us know what knapsack and dynamic programming is. In general, knapsack is a bag used by soldier or hiker to carry useful stuff for their journey, as they have to carry a long journey, so they don't carry unnecessary stuff. Similarly, in computer science, we use knapsack problem to solve such types of questions. Knapsack problem algorithm is a very helpful problem in combinatorics. Let's just explain you by one example. Like in supermarket, there are n packages which has I which has weight W. A thief breaks into the supermarket. The thief cannot carry weight exceeding M. So knapsack problem will be solved here by explaining that which of the highest value packages thief will take away. Next slide. Dynamic programming. Dynamic programming takes divide and conquer strategy. You divide the problem solved into sub-problem. The sub-problem will further divide it into smaller sub-problems. This process will continue until you get a problem that cannot be solved easily. However, in this process of such division, you may encounter the same problem many times. The basic idea of Knapsack dynamic programming is to use table to store the solution or solve sub-problem. If you face a sub-problem again, you just need to take the solution into the table without having to solve it again. Therefore, the algorithms designed by dynamic programming are very effective. Like you can see in the diagram, a problem is further divided into sub-problem and sub-problem into smaller sub-problem. Now, Prashant will take further.
Now we will analyze the 0 by 1 knapsack problem. When analyzing 0 by 1 knapsack problem using dynamic programming, we can find some noticeable points. The value of the knapsack algorithm depends on two factors. The first one is that how many packages are being considered, and the second one is that the remaining weight which the knapsack can store. So therefore we have two variable quantities. With dynamic programming, we have useful information like the objective function will depend on two variable quantities and the table of options will be a two-dimensional table. Next slide. Now if calling Bij is the maximum possible value by selecting in packages with weight limit j, the maximum value when selected in n packages with the weight limit m is Bnm. In other words, when there are I packages to choose, Bij is the optimal weight when the maximum weight of the packages is Bij is less than equals to j. Now basis of dynamic programming. So we have to consider if it is better to choose package I or not. From there we have got the recursive formula as follows. So this is a recursive formula. It is easy to see B0j is equals to maximum value possible by selecting from 0 package. Now Divyanshu will explain you how to calculate the table of options.
Thank you, Prashant. Now I'm gonna tell about the calculation of table. You build a table of option based on the above recursion formula that Prashant told and explained to check if the results are correct, and if not correct, you rebuild the objective function B matrix of I and j column and row respectively through the creation of objective function Bij and the table of option. You will orient the tracing. Table of option B includes n plus 1 lines and n plus 1 columns. Firstly, filled with the basics of dynamic programming, line 0 includes all 0. Using recursive formula, use line 0 to calculate line 1 and use line 1 to calculate line 2 and respectively up to n it goes on. until all lines are calculated. Now, as if we can see in the matrix, the first row is 0, that first 0 line is 0, and we can calculate the first line using the second one, and it goes further for up to n. Now Piyush is gonna explain the algorithm and code.
In this article, we will solve 0 by 1 knapsack problem using dynamic programming. Dynamic programming is a algorithmic technique for solving an optimization problem by breaking it down into similar subproblems and utilizing the fact that the optimal solution to the overall problem depend upon the optimal solution its sub-solution. 0 by 1 Knapsack is perhaps the most popular program under dynamic programming. It is also a great problem to learn in order to get a hang of dynamic programming. Let's see the code for the 0 by 1 Knapsack programming. N plus 1, W plus 1, the row of table correspond to item from 0 to n. The column of the table correspond to weight limit from 0 to W. The index of the very large cell of the table would be N and W. Value of the cell with index ij represent the maximum profit possible when corresponding item from 0 to I and the total weight limit as j. Table is equal to 0 for x in range W plus 1. We will be using nested for loop to travel through the table and entire in each. We are going to fill the bottom of the manner. If I is equal to 0 or j is equal to 0, table ij is equal to 0. This part of the code is responsible for setting the 0 row and the column to 0. If Wt I minus 1 is less than equal to j, this line of code checks that the weight of the ith object is less than the total weight permissible for the cell j. Table ij is equal to max value I minus 1 plus table I minus 1 j minus Wt I minus 1 table I minus 1. This line of the code is responsible for selecting the maximum out of two optimal available to us. Else table ij is equal to table I minus 1 j. This part of the loop is accessed when the weight of ith object is greater than the permissible limit j. When we are done filling the table, we can return the last cell of the table as the answer return table and W. Thank you, sir.